What up? Alright, so have a little project going on. Today I am putting on a bunch of fan cycling switches on these units that were installed a couple of years ago. What's going on is that we're tripping up a high head quite often when we're in that weird 56 to 63 outdoor air temp. So it's pretty much when the economizer is calling for a mechanical stage of cooling for first stage. Only your first fan comes on. The RTRM don't allow the second fan to turn on till this one's the second fan, till like the outside air temp is like above 63 or 65 or whatever. So to avoid doing that, what I'm going to do is put on some fan cycling switches on the discharge, that one, on both, pretty much piggybacking from when it's getting their 24 volts through the switch to the contactor. Now, as you can tell, this auxiliary relay on each of these contactors go to the red wire, which goes to this plug, which energizes this fan. So when either stage is calling, this contactor would be pulled in, energizing the first fan. The second fan don't turn on, and then what happens? This head pressure builds up, or it doesn't matter, because not much air is going to go through this coil. It's just going to bypass going through here and out there. So it's just so when the head pressure builds up, which these are cut in at 400 and a cut out at 300. So fan will cut on at 400, cut out at 300. And even when the outdoor temp does rise above 63 or 65 or whatever, the RTRM will send the power to your contactor, bring on the second fan whenever your DX is going. So that's how that is. So when it's calling, it's going to ignore whether these switches are open or closed. It's going to be irrelevant. So for the first stage though, you notice if I just had that switch plugged straight on there, it's probably going to come out and hit the back end of the panel when I put it back on. That's not okay. So to avoid that, got some T's and some nylon. Put on each circuit, and yada yada. A second circuit, I'm not gonna put a T on because it's far back in there, and I have a liquid line tap. So when I'm plugged up, anyways, check and charge, I want liquid pressure, anyways. First stage got one up there somewhere. There it is, first stage. Second stage, liquid here. And out it goes. So let's get started before I run out of time for the day. It's 2:03. So yeah. Alright, we're all ready, we're all set, we're all ready, good to go. So we're all wired up here, we're piggybacking, this 24 volts goes to that circuit, this 24 volts goes to this circuit. When either one of these are going, 24 volts will go through the switch, head pressure goes above 400, it will close and send it back to this, ignoring whether or not if we got 24 volts here, it's going to have 24 volts there, goes to the coil, goes back to common, energizes contactor, pulls in, second fan runs. When it gets above 63, 65, whatever the logic of the controller is, it's not going to matter at that point. The second fan's going to run whenever our DX stages are going. But when it's below that point, we're just calling for cooling because this is a hot part of the building here. We got a bunch of machines and shit that produce a lot of heat. So usually we're calling for cooling even if it's quite below your typical lockout set point for most of the time would be about 60 degrees for your DX. Some places are even 65 degrees. But in this scenario, we don't want air bypassing the coil. We want it to go through the coil. So, but if this is going, and this one is not, when this is pulling air through, air gets sucked in here, totally bypassing, totally gets rid of the point of, you know, having the condenser there. It just builds up pressure, head pressure trips 3 or 4 times within the hour or whatever, it locks out. You have to recycle the power and all that. You have to wait, you know, it goes to your VFD, it's got capacitors, they got a discharge, and all this, that, yada, 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 yada. So, the way I did it here is, you know, like I said, I've taken 24 volts. So it'll have 24 volts whenever, whichever stage this decides to pull on. Usually first stage is first, so let's do this one. 24 volts will go to your coil, energizing the contactor. 24 volts will also be sent to the switch. Now the switch will close when the head pressure gets above 400, and it'll send power to my contactor, which will bring on my second fan till it cuts out, which is 300 psi, and it'll shut off till head pressure builds up again, and it's just head pressure control and lower ambient conditions. Now, it's not going to matter if this switch is open or closed when it's above 65, because it'll be getting 24 volts from the board anyway. So, so it's just to help prevent nuisance head pressure trips during these early spring months, you know, late fall months, you know, when the cooler weather happens and we still need DX cooling, you know, like, you know, the economizer won't be able to bring the mixed air temp below 55. It's gonna be like, oh shit, we gotta need some mechanical cooling, bring on the stages, and, you know, and it's okay to economize. It's obviously not okay to bring on the second fan via logic, so I'm gonna have to force it. So this is my idea of forcing it without just standing up here with a fucking screwdriver. And, well, that's a bad idea. Whenever I push in contactors, I always use like my lead to my meter. I know it's insulated, so I don't, and this is 460 volts, so yeah. This is your dual voltage transformer. Those things are just lovely, aren't they? Yeah. So, my zip ties out of here. You know, I try to keep it a little bit nice, you know. Have my wires routing and I let it join in with the rest of them. You know, try not to make a nuisance mess. I mean, I know Trane doesn't lay them as nice as, you know, the Aeons do. The Aeons are, you know, beautiful units. But, you know, I guess you don't always have to have Panduit and whatnot, you know, in your units. You just got to make do with what you have, and this is what I have. So this is the first unit I did. I still have 5 more to go. Those 2 over there, that one there, I think that one there, there's one over there that I did the temperature control a few videos back or whatever. If any of y'all watch my content, it'd be cool if you did. But anyways, oh yeah, I do remember when I did my MB bag video, my last video, I had this sitting by my bag and I didn't even talk about it. But yeah, I love these things. These are the Catapult by Klein. And you just cut your wire through there. The little tooth or whatever pulls the wire down, strips it, pulls it. Nice, clean cuts. I love this thing, but I don't really use it every day. I mean, my dog chewed up the handle, but whatever. But yeah. So yeah, that's what's going on here. I mean, shit, this is head pressure control and all these circuits. Doing these 6 first. I'm still waiting on 12 more switches, and I have some newer units over in that area that need them because they do the same thing. Well, that's my 3-stage coolant thing. Okay, so yeah. I mean, I don't mind the Trane units. They're nice. They're nothing really to complain about. I mean, I kind of hate how hard it is to get information when you're having intermittent problems or weird-ass economizer problems. Like ECA boards, like, spazzing out and shit, but those type of things there's only so much you can do. But situations like this, when you notice nuisance head pressure trips, you look at the outside air temp, you know that your second fan ain't going. Anyone with experience and knowledge in HVAC can only imagine that your head pressure is climbing because your air is bypassing. But that's all for today. I gotta get out of here. So like and sub if you want. I'm hoping to put more vids out eventually. Like I said, I hope some of these compressors die so I can change them out. Not really. Well, I don't mind it. So a lot of people think it's a hassle or it's rocket science. It's really not. You just, take out the refrigerant, purge it with nitrogen, unbraze, take the shit out, put the new shit in, braze it in, change the filter dryer, pull the good vacuum. Oh yeah, and don't forget to purge with nitrogen when you're brazing. That's the key thing, especially when these microchannel, man, and the TXVs. Holy shit. You know how many TXVs I found fucking failed because some dipshit from years ago didn't fucking purge with nitrogen, like while brazing. Like, I mean, I guess not everybody knows that. It's been more prevalent now, like in the last 7 or 8 years to do that. But I mean, yeah, it does make a hell of a difference. But blah blah blah. I'm gonna shut up and end the video. So yeah, eventually these 4 units are gonna be replaced. This, it's what they do. There's a 1988 unit way on the other roof, like way below. I might actually shoot a video of that before that one goes. So that one's going too, if the this place's budget permits. It's just like efficiency standard. These are 2005s. I mean, you can tell like this one's having a leak, and there are 22. So, I mean, yeah, it is what it is. Or that might be just a stain I didn't clean off from a repair I did before. It's leaking again. You know how it is. Those discharge headers leak all the time, or the bulk plate. But yeah, like and sub, man. Thanks for watching. I'll see you on the next one.